Reflection of light from curved surfaces, spherical mirrors. So far, we have discussed the reflection of light from plane surfaces like that of a plane mirror. When a parallel beam of light rays fall on a plane mirror, it is reflected as a parallel beam. So, a plane mirror changes only the direction of incident light rays. It does not converge or diverge the parallel rays of light. We will now describe the spherical mirrors which can converge or diverge the parallel rays of light which fall on them. Please note that the spherical mirrors have a curve-like surface, so they are also known as curved mirrors. We will first define the spherical mirrors and then study the reflection of light from the spherical mirrors. A spherical mirror is that mirror whose reflecting surface is the part of a hollow sphere of a glass. The spherical mirrors are of two types, concave mirrors and convex mirrors. A concave mirror is that spherical mirror in which the reflection of light takes place at the concave surface or bent-in surface. A concave mirror is in which the concave reflecting surface has a concave surface. The opposite surface having short oblique line is the non-reflecting surface. Example of a spoon. The inner shining surface of a steel spoon is an example of concave mirror. We use only the side view of a concave mirror as shown. If, however, we look at a concave mirror from the front, it appears to be like a piece of thin round glass whose front surface is shining and bent inward, whereas back surface is covered with a paint and bulging outward. A convex mirror is that spherical mirror in which the reflection of light takes place at the convex surface or a bulging out surface. A convex mirror example is spoon. The convex reflecting surface having short oblique line is non-reflecting surface. The backside of a shining steel spoon is an example of convex mirror. If we look at a convex mirror from the front, it appears like a piece of thin round glass whose front shining surface is bulging outward, but the back surface covered with paint is bent inward. A spherical mirror, concave or convex, works on the reflection of light. Center of curvature, radius of curvature, pole, and principal axis of spherical mirror. The center of curvature of a spherical mirror is the center of the hollow sphere of glass of which the mirror is a part. The center of curvature of a mirror is represented by the letter C. The center of curvature of the concave mirror is the center of curvature is not part of the mirror. It lies outside the reflecting surface of the mirror. It should be noted that the center of curvature of a concave mirror is in front of it, but the center of curvature of a convex mirror is behind it. The radius of curvature of a spherical mirror is the radius of the hollow sphere of glass of which mirror is a part. The center of a spherical mirror is called its pole. In other words, the middle point of a spherical mirror is called its pole. The pole of a spherical mirror lies on the surface of the mirror. The straight line passing through the center of curvature and pole of a spherical mirror is called principal axis. The principal axis is normal or perpendicular to the mirror at its pole. That position of a mirror from which the reflection of light actually takes place is called aperture of the mirror. The aperture of a spherical mirror is represented by diameter of its reflecting surface. The aperture of a mirror represents the size of the mirror. Principal focus and focal length of a concave mirror. The principal focus of a concave mirror is a point on its principal axis to which all the light rays which are parallel and close to the axis converge after reflection from the concave mirror. Parallel beam of light rays falling on a concave mirror. The principal focus of the concave mirror is where parallel rays of light converge at a point after getting reflected from the concave mirror. Since all the reflected light rays pass through the focus of a concave mirror has a real focus. The focus of a concave mirror is in front of the mirror. Since a concave mirror converges a parallel beam of light rays, it is called a converging mirror. The focal length of a concave mirror is the distance between the pole and the principal focus. The focal length of a mirror is denoted by letter F. How an image of sun can be formed by a concave mirror. The sun is at a far off distance from us, so the sunlight rays reaching us are parallel rays. An image of the sun can be produced by a concave mirror at its focus. This can be done by performing a simple experiment as follows. We take a concave mirror and point it towards the sun. Hold a piece of paper in front of the concave mirror in such a way that the sunlight reflected by concave mirror falls on the paper. A small patch of bright reflected light will appear on the paper. Adjust the distance of paper from the concave mirror in such a way that the sharpest point of bright light is obtained. This sharp point of light on paper is the image of sun formed by the concave mirror. This image of the sun is formed at the focus of the concave mirror where the paper is held by us. If we keep this piece of paper in this position for a few minutes, the paper would start burning at the point of sun's image and a hole will be formed in it. This is because the concave mirror converges a lot of sun's rays to small point on paper. The heat energy of these concentrated sun rays burns the paper. Please note that the image of the sun formed by the concave mirror is real because it can be received on screen, such as a sheet of paper. Since the sun's image is formed at the focus of the concave mirror, therefore, the distance of sun's image on paper from the concave mirror gives us an approximate value of the focal length of the concave mirror. Principal focus and focal length of a convex mirror. The principal focus of a convex mirror is a point on its principal axis from which a beam of light rays initially parallel to the axis appears to diverge after being reflected from the convex mirror. Each ray of light is reflected by a convex mirror and the reflected rays diverge or spread out from the mirror surface. All the reflected rays can be produced backwards through dotted lines so that they appear to meet at a point F behind the convex mirror. To a person looking into the mirror from the left side, all the reflected rays appear to be coming from the same point F behind the convex mirror. This point F is the principal focus of the convex mirror. It should be noted that the reflected rays do not actually pass through the focus F of a convex mirror. Therefore, a convex mirror has virtual focus. Another point to be noted is that the focus of a convex mirror is situated behind the mirror. The focal length of a convex mirror is the distance from the pole to its principal focus. Thus, the distance PF is the focal length of the convex mirror. A plane mirror neither converges parallel rays of light nor diverges them. The focal length of a plane mirror can be considered to be infinite or infinity, which means very, very great or limitless. Relation between radius of curvature and focal length of a spherical mirror. For a spherical mirror having small aperture, the principal focus lies exactly midway between the pole and the center of curvature. So the focal length of a spherical mirror, a concave or a convex mirror, is equal to half of its radius of curvature. If small f is the focal length of a spherical mirror and r is radius of curvature, then small f is equal to r by 2. Rules for obtaining images formed by concave mirrors. When an object is placed in front of a concave mirror, an image is formed. The image is formed at the point where at least two reflected rays intersect or appear to intersect. Now, to find out the position of an image formed by a concave mirror, we use only those two rays of light starting from the object whose paths after reflection from the mirror are known to us and easy to draw. The following rays of light are usually used to locate the image formed by concave mirror. We can call them rules for obtaining images in concave mirrors. Rule 1. A ray of light which is parallel to the principal axis of a concave mirror passes through its focus after reflection from the mirror. This is shown here. We have a concave mirror and its principal axis, the center of curvature and focus. A ray of light is parallel to the principal axis of the mirror. It strikes the mirror at a point and gets reflected. After reflection, its path changes and it passes through the focus and goes in the direction which is different. Rule 2. A ray of light passing through the center of curvature of a concave mirror is reflected back along the same path because it strikes the mirror normally or perpendicularly. Thus, a ray of light passing through the center of curvature of the concave mirror falls normally or perpendicularly on the mirror at a point and gets reflected back along the same path. It should be noted that we have put two arrowheads on the line which point in the opposite directions. The arrow pointing from the left to right indicates the direction of incident ray, and the arrow pointing from right to left indicates the direction of reflected ray. The ray of light passing through the center of curvature of a concave mirror is reflected back along the same path because it strikes the concave mirror at right angles to its surface, due to which the angle of incidence and angle of reflection both become 0. Rule 3. A ray of light passing through the focus of a concave mirror becomes parallel to the principal axis of the reflection. This rule is just the reverse case of the first rule, and it shows here the incident ray is passing through the focus F. Of the concave mirror. It strikes the mirror surface at a point and gets reflected. After reflection, it becomes parallel to the axis and goes in a different direction. Rule 4. A ray of light which is incident on the pole of a concave mirror is reflected back, making the same angle with the principal axis. Here a ray of light is incident at the pole of the concave mirror, making an angle of incidence with the principal axis. It gets reflected along the direction such that the angle of reflection is equal to the angle of incidence. Please note that if ray of light is incident on a concave mirror along its principal axis, then it is reflected back along the same path because it will be normal to the mirror surface. The angle of incidence as well as the angle of reflection for such a ray of light will be 0. Formation of different types of images by a concave mirror. The type of image formed by a concave mirror depends on the position of object in front of the mirror. We can place the object at different positions or different distances from a concave mirror to get different types of images. For example, we can place the object between the pole and the focus, at the focus, between the focus and the center of curvature, at the center of curvature, beyond the center of curvature, and far off distance called infinity. Please note that in all our ray diagrams, the object and arrow pointing upwards will be placed on the principal axis. So a ray of light coming from the bottom of the object always travels along the principal axis and gets reflected back along the same path. We do not put arrows on the principal axis to show this ray of light. Case 1. Image formed by a concave mirror when the object is placed between the pole and the focus of the mirror. An object is placed between the pole and the focus of a concave mirror. That is, the object is within the focus of the concave mirror. To find out the position and nature of the image, we draw a ray parallel to the axis. This ray gets reflected and then passes through the focus F. A second ray of light passing through the center of curvature strikes the mirror normally and gets reflected back along the same path. The two reflected rays are diverging rays and therefore do not intersect each other on the left side. The reflected rays are produced backwards. Shown as dotted lines. On producing backwards, they appear to intersect at a point. To get the complete image of the object, we draw a perpendicular to the axis from this point. Thus, the image of the object formed by the concave mirror is this image. Now an eye at position X sees the reflected rays as if they have come from points behind the mirror. Since there is no actual intersection of the reflected rays, so the image is a virtual image. This image can be seen only by looking into the concave mirror. It cannot be obtained on a screen. We can see that the image is same side up as object. So it is an erect image, and if we compare the size of the object and its image, the image appears to be bigger in size than the object. Thus it is an enlarged image or magnified image. From this discussion, we can conclude that when an object is placed between the pole and the focus of a concave mirror, the image formed is behind the mirror, virtual and erect, larger than the object. It is clear from the above discussion that to obtain a magnified and erect image with a concave mirror, the object should be placed between the pole and the focus at the concave mirror. That is, the object should be placed within the focus of the concave mirror. For example, if the focal length of a concave mirror is 10 cm, then its focus will be at a distance of 10 cm from the pole of the mirror. So to obtain a magnified and erect image with this concave mirror, we will have to place the object at a distance of less than 10 cm so that it remains between the pole and the focus. Thus, if we place the object at a distance of say 8 cm from this concave mirror, the object will be within the focus and magnified virtual and erect image will be formed behind concave mirror, which can be seen by looking into the concave mirror. If we hold a matchstick within a focus of a concave mirror, then a magnified virtual and erect image of the matchstick is seen on looking into the concave mirror. This also explains the use of a concave mirror as shaving mirror. When the face is placed close to concave mirror so that the face is within its focus, the concave mirror produces magnified image which is erect. Since large image of the face is seen in the concave mirror, it becomes easier to make a smooth shave. Thus, while using a concave mirror as a shaving mirror, the face should be close to the concave mirror. For the same reason, concave mirrors are also used as makeup mirrors by women for putting on makeup, such as painting eyelashes. In order to use concave mirror as a makeup mirror, the face is held close to the concave mirror so that it lies within the focus of the concave mirror. Dentists use concave mirrors to see the large image of the teeth for examining the teeth of a person. For this purpose, the dentist holds a small concave mirror in such a way that the tooth lies within its focus. A magnified image of the tooth is then seen by the dentist in the concave mirror. Since the tooth looks much bigger, it becomes easy to examine the defect in the tooth. Case 2. When the object is placed at the focus of a concave mirror, if the object is placed at the focus of the concave mirror, the parallel ray of light coming from top of the object get reflected and pass through the focus, giving us reflected ray. A second ray of light passing through the center of curvature is reflected back along same path, giving us another reflected ray, EY. We find that the reflected ray are parallel to one another. These parallel rays will intersect at a far off distance to form an image at infinity. And since the image is formed at infinity, it is not possible to show it in our diagram. From this discussion, we conclude that when an object is placed at the focus of a concave mirror, the image formed is at infinity. It is real but inverted and highly magnified. Suppose we have a concave mirror of focal length 10 cm. The focus will be at a distance of 10 cm from it. So by saying that an object is placed at the focus of the mirror, we will mean that the object is placed at a distance of 10 cm from the concave mirror. In this case, the concave mirror converts the diverging rays of light coming from the object into a parallel beam of light rays. When a lighted bulb is placed at the focus of a concave mirror reflector, the diverging light rays of the bulb are reflected by the concave reflector and then reflected to produce a strong parallel beam of light. This explains the use of concave reflectors in torches, car headlights, and searchlights to produce a strong beam of light which travels a considerable distance in the darkness of night. Case 3. When the object is placed between the focus and center of curvature. The object has been placed between the focus and center of curvature of a concave mirror. The ray of light parallel to the principal axis gets reflected at a point and then passes through the focus F. A second ray of light passing through the center of curvature on the mirror surface returns along the same path. Thus we have two reflected rays which are converging in the downward direction. If we extend these rays further in the downward direction, they actually intersect at a point. Thus the point is the real image of point of the object. To get the complete image, we draw perpendicular to the axis from the point. Thus the real image of the object is obtained and it can be received on a screen. For example, if we take a lighted candle as the object, then the image of its wick will be formed on a white screen placed at a image position. If we look at the image, we find that it is wrong side up, having arrowhead at its bottom, so that we say that the image is inverted. The side of image is larger than the object, so that image is magnified and it has been formed beyond the center of curvature of the mirror. From the above discussion, we conclude that when an object is placed between the focus and the center of curvature of a concave mirror, the image formed is beyond the center of curvature, real but inverted, larger than the object. Please remember that a real image is always inverted and a virtual image is always erect. Suppose we have a concave mirror of focal length 10 cm, then its focus is a distance of 10 cm and center of curvature will be at a distance 2 into 10, 20 cm from it. Now by saying that the object is placed between the focus and center of curvature of this concave mirror, we mean that the object is at any distance between 10 and 20 cm from the concave mirror. For example, it may be at a distance of say 15 cm from the concave mirror, and by saying that the image is formed beyond center of curvature, we mean that it is at a distance greater than 20 cm from the concave mirror. Case 4. When the object is placed at the center of curvature of a concave mirror. When the object is placed at the center of curvature of the concave mirror, the ray of light which is parallel to the principal axis passes through the focus after reflection. Now the second ray of light used is the one passing through the center of curvature, but in this case the object itself is placed at center of curvature, so we cannot use ray of light to locate the image. Ray of light passing through the focus of a concave mirror becomes parallel to the principal axis after reflection. So we now take this ray passing through the focus. It strikes the mirror at a point and gets reflected in direction parallel to the principal axis. The reflected rays meet at a point, so the real image of the point of the object. To get the complete image, perpendicular to the principal axis is drawn. The real image of the object is seen. The image is the same size as the object. It is real, inverted, and formed at the center of curvature, where the object itself is placed. From this discussion, we conclude that when an object is placed at the center of curvature of a concave mirror, the image formed is at the center of the curvature. It is real but inverted, same size as the object. Case 5. When the object is beyond the center of curvature of the concave mirror. When the object is placed beyond the center of curvature of the concave mirror, the image formed is between the focus and the center of the curvature. Real and inverted, smaller than the object. Case 6. When the object is at infinity. When the object is at infinity from a concave mirror, the image formed is at the focus, real and inverted, much smaller than the object. When the object is at a focus of concave mirror, the image is formed at infinity. When the object is at infinity, the image is formed at the focus of the concave mirror. Please note that when the object is kept at infinity in front of a concave mirror is assumed to be a big arrow pointing upwards, then its image is formed at focus according to the ray diagram. If, however, the object kept at infinity in front of a concave mirror is round in shape, then its image is formed at the focus according to the ray diagram. The fact that when a parallel beam of light rays falls on a concave mirror, the concave mirror concentrates all the light at its focus explains the use of concave mirror as a doctor's head mirror. A concave mirror is used as a head mirror by the doctors to concentrate light coming from a lamp onto the body part of patient like ear, nose and throat to be examined. This is done as follows. A concave mirror is fixed to the front part of the doctor's head with the help of a strap. When a beam of light coming from a lamp falls on the concave mirror, the mirror focuses this light on the body part of the patient. The body part gets illuminated brightly with the light, due to which the doctor can look into the body part like ear, nose and throat. The concave metal dishes are used in dish antennas or dish aerials of televisions to receive TV signals from very distant communication satellites which are high up in the sky. The dish is a concave reflector. The dish collects a large amount of parallel beams of TV signals coming from far off satellites and converges them to its focus. The antenna or signal detector is fixed in front of the concave dish at its focus. Since the antenna is fixed at the focus of dish, it receives the strongest possible TV signals from the satellite which make our television work. The TV signals coming from satellite can be made even more stronger by using a bigger dish in the dish antenna. Please note that though the TV signals coming from the satellite are not light rays, they obey the laws of reflection of light. How to find out focal length of a concave mirror? The fact that when an object is at a considerable distance or infinity from concave mirror, then its image is formed at the focus can be used to find out focal length of a concave mirror. We focus distant object like a window or a tree on a screen by using a concave mirror whose focal length is to be determined. The sharp image of window or tree will be formed at the focus of the concave mirror. That is the distance of image from the concave mirror will be equal to the focal length of the concave mirror. The distance can be measured with a scale. It will give us approximate focal length of the concave mirror. And before we conclude this discussion, here is a summary of the images formed by a concave mirror. Within the focus, the position of image is behind the mirror, size is enlarged, and nature of image is virtual and erect. At focus, the position is at infinity, the size is enlarged, it is real and inverted. Between focus and center of curvature, the image is beyond center of curvature, it is enlarged, it is real and inverted. At center of curvature, the image is at center of curvature, it is equal to the object, it is real and inverted. If it is beyond the center of curvature, the image is found between the focus and center of curvature, the size is diminished, it is real and inverted. If the object is at infinity, the position of image is at focus, the size is diminished, it is real but inverted. Use of concave mirrors. Concave mirrors are used as shaving mirrors to see large images of the face. This is because when the face is held within the focus of a concave mirror, then an enlarged image of the face is seen in the concave mirror. This helps in making a smooth shave. For the same reason, concave mirrors are used as makeup mirrors. Concave mirrors are used by dentists to see the large images of teeth of patients. This is because when a tooth is within the focus of a concave mirror, then an enlarged image of the tooth is seen in concave mirror. Due to this, it becomes easier to locate the defect in the tooth. The concave mirrors used by dentists are very small in size. They are fitted in a frame with a long handle. The concave mirrors are used as reflectors in torches, vehicle headlights, and searchlights to get powerful beams of light. This is because when a lighted bulb is placed at a focus of a concave reflector, then the concave reflector produces a powerful beam of parallel light rays. This helps us use things up to a considerable distance in the darkness of night. Concave reflectors are also used in room heaters. The concave reflectors of room heaters direct heat rays onto the whole room. The concave mirrors are used as doctors' head mirrors to focus light coming from a lamp on the body parts of a patient, such as eye, ear, nose, and throat, to be examined by the doctor. Concave dishes are used in TV dish antenna to receive TV signals from the distant communication satellites. The concave dish collects a lot of TV signals and focuses them onto an antenna or aerial fixed at its focus so as to produce strong signals to run the television. Large concave mirrors are used in the field of solar energy to focus sun's rays for heating solar furnaces. This can be explained as follows. The solar furnace is placed at the focus of a large concave reflector. The concave reflector focuses the sun's heat rays on the furnace, due to which the solar furnace gets very hot. Even steel can be melted in this solar furnace.